In today's lesson, we are going to be talking about two key concepts. The first is going to be what are called function operations. The second is going to be what's called average rate of change. So, function operations, let's talk about those first. What we're looking to do is to combine two different functions into a single function. So on number one, it's asking us to find h minus g of x. So our function's name is actually h minus g. The way we're going to find it is we're going to take h of x minus g of x. In other words, we're going to take our two functions and subtract them from one another. Let's look and see what that's going to look like. So if we substitute negative x minus 3 in for h of x, I'm going to leave that in parentheses, negative x minus 3. Then we're going to subtract g of x, which again, I'm going to leave in parentheses. So we're going to take negative 3x squared plus 3 and plug that in for g of x. So negative 3x squared plus 3. Now, to save some space, I'm going to go ahead and move this up a little bit right here. So now, what's going to be important anytime you are subtracting is to remember to distribute this minus sign. That's going to end up making this a positive 3x squared and a minus 3. Now, the rest, what was in red, we're just going to copy down. So now we've got negative x minus 3 plus 3x squared minus 3. Now it just becomes a matter of combining like terms. Starting with our largest exponent, which was 3x squared, we're just going to leave that as 3x squared. Same with the minus x, it doesn't have anything to combine with, so we'll just leave that as is. However, the negative 3's we can combine. Negative 3 minus 3 is negative 6, and then there's going to be our answer for number 1. Number 2 is a little bit different. So notice that now we're looking to find f of x multiplied by g of x. Now f of x is 3x plus 2 multiplied by g of x, which is x to the third minus 2x. So now, rather than subtracting, we're going to be multiplying. This is where we'll have to remember to distribute. So we're going to take 3x squared multiplied by x to the third is 3x to the fourth. Remember to add your exponents when you're multiplying. Next, we'll take 3x multiplied by negative 2x is minus 6x squared. Now we'll go back and distribute the 2. So 2 multiplied by x to the third is 2x to the third. And 2 multiplied by negative 2x is a negative 4x. So now we just have to remember to put everything in order from least to greatest. And so the largest exponent is 4, nothing to combine with, so that would just be 3x to the fourth. Next highest exponent is going to be x to the third. So again, nothing to combine that with, we'll just copy it down. Next would be x squared. And last would be just x by itself. All right, let's take a look at another example. So number 3, we've got g of x is equal to x squared minus 2, f of x is equal to 4x minus 4, and it looks like we're going to be doing some subtraction. This time, though, we're going to take g of x minus f of x. So starting with g of x, which was x squared minus 2, again leaving that in parentheses, minus f of x, which it tells us is 4x minus 4. And again, make sure that that's going in parentheses. So now, since we're subtracting, we need to remember to distribute this minus sign to both of these terms. So that's a negative 4x and a positive 4. And then we'll copy down what was in red in front of that. Now it's just time to combine like terms. So first off, x squared is our highest exponent, has nothing to combine with. Next is negative 4x, again, nothing to combine with, but negative 2 plus 4 is positive 2, and then there's our final answer. Next up, we're going to have addition. So we're going to take f of t plus g of t. So f of t is t plus 5. Again, we'll put that in parentheses. Plus g of t, which is 4t plus 4. Again, putting that in parentheses. Notice that this time, though, we don't have to worry about distributing. If we distributed the plus sign, we're going to end up with the same thing. So we can actually go straight to combining like terms. So we can take t plus 4t is 5t, and then 5 plus 4 is 9. Now, this is where I'll make mention, especially on big ideas, if you have a problem similar to this that uses t, it will mark you wrong if you write 5x plus 9. The answer has to be 5t plus 9. So make sure on big ideas as you work through homework that you're using the right notation. All right, let's take a look at number 5. So now we've got f plus g of a. This is just another way of writing f of a plus g of a. So let's go ahead and add those together. F of a is 3a to the third plus 4a squared. And then g of a was 2a minus 1. All right, so now with addition, like we saw in number 4, really there is nothing to distribute, which means you can actually, if you want to, get rid of these parentheses. The parentheses are really only there so you remember to distribute. So now we just have to combine like terms and put everything in order, but if you notice, it's actually already in order for us. So we're done. On number 6, we are wanting to find f multiplied by g of x. This is the same as finding f of x multiplied by g of x. So what we're going to do, we'll take first 3x plus 2, and then we'll multiply that by 4x minus 3. Again, remember to distribute. So we'll take 3 multiplied by 4 is going to be 12, and then x multiplied by x gives us x squared. Then we'll take 3x multiplied by negative 3 is a minus 9x. Next, we'll distribute the 2. So 2 multiplied by 4, which is 8x, and then 2 multiplied by negative 3, which is a minus 6. Now we just have to combine our like terms. So 12x squared, nothing to combine with, but we'll take negative 9 plus 8 is a minus 1x, and then the minus 6 does nothing to combine with, goes at the end. So when you're combining functions using addition and subtraction, it's going to be really important to make sure that you combine like terms. In fact, that's really all you're doing, is combining like terms when you're adding or subtracting two polynomials together. Now, when you're subtracting functions, it's additionally important to make sure that you distribute the minus sign to all of the terms that are in the function being subtracted, which again we talked about, just a reminder to make sure you distribute. So our second concept that we're going to talk about is average rate of change. So average rate of change is the slope of the line between any 2 points of your function. So if you remember, linear functions have a slope which tells you basically which direction the function goes and how fast it goes there. We can do that actually with other functions, but the problem is the slope isn't always going to be the same. It might be greater in this spot, but less in this spot, because they aren't going to grow at the same rate. And so what we want to do is just find the average rate. The formula for that is over on the right-hand side, which is that you'll take f of a minus f of b divided by a minus b, which again is really just the formula for slope, and you're just looking for what is the slope between 2 points. So to give you an example, let's say you had 2 social media websites that were going to open their memberships to the public. In part A, let's compare the websites by calculating and interpreting the average rates of change from day 10 to day 20. Let's start with website A, which I'm going to do in green. So for website A, we're going to go from day 10 to day 20. So you've got your 2 x values. Let's just make this one A and this one B. And then you've got your 2 y values, which would make this one f of A, this one f of B. So now plugging those into our equation for website A, we're going to take 1,400 minus 2,150 over 10 minus 20, which 1,400 minus 2,150 is negative 750, and 10 minus 20 is negative 10, which when you simplify is 75. So that was calculating. Interpreting just means that you would say that on average, the number of members increased by 75 per day between days 10 and 20. I'll say it one more time in case you want to write this down. So the interpretation for website A is that on average, the number of members increased by 75 members per day between days 10 and 20. Next, let's find the average rate of change for website B, which I'll do in purple. So for website B, we're going to look from day 10 all the way to day 20. So again, let's make day 10A and day 20B. That would make f of A, whatever the y value is, which halfway between 6 and 1200 would be 900, so that's going to be our f of A. Whereas for B, we are right at 1,800, so there's our f of B. So plugging those into our equation, we're going to take f of A, which was 900, minus f of B, which was 1,800, divided by A minus B, which is 10 minus 20, which ends up being 900 minus 1,800 is negative 900, divided by 10 minus 20 is still negative 10. And when we simplify that, we'll come up with 90. So our interpretation for website B would sound similar to website A. We would say that on average, website B increased by 90 members per day between days 10 and day 20. So now, in part B, predict which website will have more members after 50 days. Well, obviously we don't have 50 days, but if we look at the average rates of change, one of them is much greater than the other. B, it looks like, is increasing at a higher rate, at a higher average rate of change of 90. So at this point, it really looks like website B is probably going to be the one that will have more members after 50 days. All right, that's it for this video. In our next lesson, we're going to be talking about piecewise functions. Until then, have a good rest of your day.